This is Honors Algebra 2 Pre-Calc. We're doing section 2.5, which is inverses of functions. So on page 118 in your book, you'll see the inverse of a relation. So if a relation consists of the ordered pairs x comma y, the inverse relation, or the inverse of the relation, you can say either, consists of all ordered pairs y comma x. So the domain of the inverse is the range of the original because the x's and y's got switched. And the range of the inverse is the domain of the original because, again, the x's and y's got switched. In terms of notation, if we have some y equals f of x that is a function, then its inverse, so its inverse is written as f inverse of x. So that's how we read this, f inverse of x, which is read f inverse of x. Note that this is not the same as writing the quantity f of x all to the negative 1, which would mean a 1 on top of an f of x. So this inverse notation with the f and then the inverse is between the f and the x, that means the inverse function of f of x, okay? So we're going to walk through some examples and figure out how we can find some inverses. One of the things worth noting is that we're going to talk about whether an inverse is a function or not a function, because not every inverse is a function, just like not every relation in the first place is a function. So let's walk through some examples. So what we're going to do in example 1, okay, is we're going to find the inverse of the relation. Is the inverse a function? All right, so all right, cool. So we're going to find the inverse of each one of these. So the inverse, right, the inverse of this would be essentially 2 comma 1 instead of 1 comma 2, right? Negative 3 comma 6 instead of 6 comma negative 3, and 1 comma 8 instead of 8 comma 1, right? And because there's no repeats, so what I want you to notice is there's no repeats in these x values, right? So this is a function, right? This inverse is a function. The inverse of this b, right, would be a table where instead of writing 5 comma 6, I write 6 comma 5. Instead of 2 comma 1, negative 1, I write negative 1 comma 2. And instead of 3, 6, I write 6, 3. Because these two 6's appear, this is not a function. Right? Now, another way that we might see this is we might see, we'll go ahead and put a C here, we might see this as a list of ordered pairs, right? So I wrote the ordered pairs as a table, but you might see it as something like 3, 1, 6, 0, 5, 2, and 4, 0, right? And if you wanted the inverse of this, right, so the inverse would be, instead of 3 comma 1, I do 1 comma 3. Instead of 6 comma 0, I would do 0 comma 6. Instead of 5 comma 2, I would do 2 comma 5. And instead of 4 comma 0, I do 0 comma 4. And see how these zeros repeats? This is not a function, okay? So again, inverse essentially means flip the x's and the y's. X becomes y, y becomes x. Let's do a P1 that's similar. So we'll do P1, and I'm just going to erase some numbers for you. Again, this is probably not super stressful yet. Hopefully it doesn't get super stressful. Let's do 0, 2, 5, 1, 3, negative 4. Let's do 5, 2, and 3, 8. And for this one, let's do cool. All right, so go ahead and find the inverse. Sorry, that last one is a 0 comma 6. My bad. Didn't realize you couldn't see it. So the inverse of this guy, right, my inverse is going to be 2, 0, 1, 5, negative 4, 3. I just switched the x's and the y's. The inverse of this guy, oh, and no repeats here, so this one's a function, right? The inverse here is going to be 8, 6, 2, 5, and 8, 3. The 8s repeat, so it's not a function. Right? And then over here, my inverse is going to be 1, 2, 8, 3, 5, 4, 6, 0. I should have commas between all these. I'm just lazy. And that is a function because the x's don't repeat. Okay, so that's a quick intro into how we would find inverses using tables or lists of ordered pairs. Now, let's talk about how we can find an inverse with an equation. So if we're asked to find an inverse with an equation, so when it's a list, you just reverse all the points, right? That's great. But so how do we find the inverse from an equation? So if we want the inverse from an equation, step one, we're going to switch the x and y, like literally physically switch them, and I'm walking through that in a sec. Then we're going to solve for x, or sorry, solve for y rather, my bad. Sometimes my brain turns off a little bit. Solve for y, and then rewrite in inverse notation. All right, so let's walk through that in an example 2. So in example 2, I'm going to give you f of x equals 3x minus 2. Okay, and we're going to find the inverse function. So first thing you should probably do is rewrite this with a y, right? Because f of x is the same as y. So step 1, switch the x and the y. Okay, so I'm going to switch this and make this x equals 3y minus 2. This is the thing you can only do when you're finding an inverse function. You can't just go around switching variables, right? Now I'm going to solve for y. So to do that, I'm going to go ahead. So now I'm going to solve for y, right? So I'm going to add the 2 over, right? I'm going to do subtraction and addition first, right? So we do subtraction and addition. Then we do our division and multiplication, right? We're doing that SAD method that we practiced. And I'm going to leave the whole thing over 3. You could make this, so I'm going to leave it as x plus 2 quantity over 3 equals y. But the other way, if you like this better, you could do it as x over 3 plus 2/3, right? Or you could do it as a 1/3 x plus 2/3. I like this best because it's easiest. The third thing I'm going to do is I'm going to replace that y with the inverse of this function. So I'm going to get f inverse of x equals x plus 2 all over 3. And that's the way I would leave it. If you liked it in any of these options better, that would also be right. Right? Those are all the same answer. I think that this is the laziest and therefore the best answer. So again, when I have an equation and I want to find the inverse, I'm going to, if you have an f of x, go ahead and replace it with a y. Now you're going to switch the x and the y, solve for y, and then rewrite with your function notation, and that's it. And the solving is pretty much always SAD map, right? So I'm going to give you a P2 that's similar, right? And we'll just squeeze that guy right in here. So for P2 like E2, let's use g of x. So let's do 4x plus 5. Okay, so same thing, I want you to find g inverse, right? So pause me if you don't want me to do it. Okay, so I'm going to go ahead and remember that that's a y, and some of you aren't going to need that step, but if you do need it, it's fine. So then I'm going to switch, right? And that's something I can only do when I'm finding an inverse, so x equals 4y plus 5. And then I'm going to go ahead and solve. So I do my subtraction and addition first, right? So subtract the 5 over and get x minus 5. So, solving if you needed the step numbered. So I subtract the 5 over, and then I do my division and multiplication, and I get x minus 5 all over a 4 is my y. And then the last thing I do is I make sure that I have the right notation. Notice that this function was not f, it was g. So this should be g inverse of x equals an x minus 5 all over 4. Now, if you wanted to make it a different version of this, if you wanted to make it 1/4 x minus 5/4 or some other version, that's fine, but this is the laziest and easiest version. Cool, so we're going to stop it at this video, and then we'll keep moving forward after, okay?